Hey dudes, how's it going? Okay, we're going to be looking at chapter 2 for the next week, maybe 2 weeks, while we get sorted out at school. And yeah, um, let's begin by sharing the screen. We are on, oops, we are on page, what's that? What page is that? 2.1, chapter 2. We're looking at broken line graphs today. And what I want to do, I hate that. There we go. Annotate, draw, screen. Yeah, green. Okay, broken line graphs is probably the most common that you've seen. With COVID going on, you see a lot of graphs like that, line graphs and stuff like that, broken line graphs. And what broken line graphs do is that they go from data point to data point to data point to show up ups and downs in data. And what they're used for is to answer questions that you would not normally be able to pose or respond to if all of the data was just in a table form. It was just listed out, and you looked at the data and you were asked a question about it, you probably couldn't answer it. But if you graph it, then you can. Okay, so so normally, I'm just going to look down here. So the title of the graph and the labeling of the vertical and horizontal axis tell you what the graph is about. Okay, so you need to be reading those things. Say, oh, okay, I understand what this is. Now, there's two terms here that are what's the word? Sometimes confusing for students, and that is the independent and the dependent variable. So basically, the independent variable is what goes along the bottom. Independent means that you don't have a control over it. The dependent variable, which is on the y-axis, always on the y, well, it's not always, but 99.99% of the time it's on the y-axis. What that does, that is what you're measuring, okay? So that may not help your thinking. So for this course, let us say this, that the independent variable, whatever is along the bottom, is time, okay? And you'll see that for this course at least, generally is true, okay? So let's, I need to stop sharing so I can change pages and start the process. Okay, so I am sharing screen, share, annotate, draw. Okay, so here's a graph of snowfall in centimeters over a month in Regina, Saskatchewan, which is a good reason for not to live in Regina, Saskatchewan. So now the question is, okay, what questions can we ask? Well, there's three there. First one is, what is the largest snowfall, what month? And so you simply look at which is highest. It is here. And so to determine that, you have to go across to the Y scale, the measurement scale, and you have to estimate where that crosses. Now, thankfully, they have hash marks in between, and there's 5 hash marks between 20 and 25. So that means that this hash mark is 21, where this falls. So December was a big month, the biggest month, 21 centimeters. Next question, what 3 months was there no snowfall? Well, big surprise, the summer months. It's kind of crazy that you're looking at September and they're already getting snow. Ooh, ugly. Anyway, I digress. Next question, which is my favorite question, is what month is the average snowfall approximately twice as much as the average October snowfall? Well, October snowfall is here, okay? And so what is that line? Well, again, we go across, crosses at 7. So if this is 7, what month is it 14? Now we go across to the scale, go up the scale to 14 and say, who lives at that address? If I go across, I find that there is one here and there is one here. So in fact, there are 2 months of the year with more snowfall, twice the snowfall as October does. Okay, let me see now. I have to stop sharing and change my page. It's one thing I do not like about this program is that I have to do that. So now you are on the hook to do questions 1, 2, 3, 1 to 3, and come back to me when you hit page 63. So pause now, and I'll see you in about maybe 10 minutes or so. Okay, you're back. Awesome. Good to see you again. Of course, I can't really see you, but that's okay. I'm going to look at page 63 now. And this is a, okay, so we've got a small business owner here, and he wants to know if he can give his people a raise. He has all this data here for, come on, where's my, there we go. So he's got all this, he's got all this data here spanning 10 years. And so these are profits in thousands of dollars. And so some of you would be able to look at it and say, oh yeah, he can do that. But maybe not, maybe it's not as obvious, okay? Because there are some issues as well. So the first thing you have to do is you have to graph the line, graph the data on the line. Now, I've already showed you how to do that. Draw the horizontal, put down your timeline, data up, pick your highest one, make that your top, put increments up to that, evenly spaced increments, and then plot your data points. So that is the first thing. So general trends, there's something called a trend line. And what a trend line is that it is meant to cross through as many data points as possible, knowing that there will be data points that will not fall on or near the line. So if so really it's easier done, like doing this digitally is really difficult. But if I had a ruler on the paper, it's easier to fudge the ruler until I get something that I'm happier with. So you may get a better data trend line than I do, but I'm going to give it my best shot. So I'm going to say data trend line is going to be about here, somewhere like that. And so now you see that on either side there are data points that don't actually fall. As a matter of fact, I've only really got 2 that actually fall on the line. This guy's really close. This guy's really close, and these guys are pretty close. And we have these outliers. That's actually a technical term. Outliers is something that does not conform. So 2007 is a huge outlier. That was a sucky year for Jacob, man. But generally speaking, you can see that his business continues to grow in profits. So it's going up. So the moral of the story is Yeah, his decision, but he is in a good position right now to, like, not just right now, but showing the growth over the years. He's in a good position to give his people a raise. Okay, so let me see where we go from here. Yes, so now you're on the hook for drawing drawing some uh, drawing some graphs. So let me walk through the first one with you, just as an example. So so um, you don't overdo it. I think that's, if anything, the likelihood is that some of you may overdo this and get frustrated and say, I hate this. So the first thing you want to do is you want to draw a horizontal line. So you draw a horizontal line, okay, and draw a vertical line. So go up from here. So that's how much space I've got to work with. So that's where my graph has to be. So now what I need to do is I need to put the hash marks, like where's stuff going to be. So if my first time goes on the bottom, right? Time always goes on the bottom. So I've got 8 weeks. So the end of this is going to be 8 weeks. And this is going to be 0 weeks. Middle, I'm estimating, I'm just eyeballing this. 4, 6, about there. 2, so 1 is going to be about here. So it's 1. Here's going to be 3. Here's going to be 5-ish. 5. And 7. Now right away you can look at mine and you say, "Hey, those are not even." No, I get that. They're not even. I try to make them as even as I can, but I'm not stressing about it. See, I'm not stressing. It's all good. So 32 is the biggest number right there. So I'm going to make this 32. 32. That means 16 is going to be about here. And if I half these, so this is going to be 8 here. And so about 24 is going to be out there. Okay. Now all I do is I go data point by data point. Let me change my color. So the first one, week 1 is 20. Well, okay. So 20 is about halfway. Is that halfway? It's about halfway between 16 and, is that right? Yeah, 16 and 24. Halfway is about 20, okay? So I'll put my data point there. Okay, whoa. Number 2 is 22. So 22 is partway between 20 and 24. I'm not measuring anything, I'm just putting it. Now, because we are so ballparking this, we have to show that we understand that our data point may not be exactly where it's supposed to be. So how you do that is you draw a little circle around it. Like that. Draw a little circle around it. And what that tells the viewer is that I have a high degree of certainty that the data point is within that circle. Exactly where, I don't know. I've done my best, but that's it. Now, I'll do one more. 3 is 18. So 3 is 16, so it's about here. Oops, wrong place. So it's the 318. It's between the two. Okay. Now, when you go to draw your lines, you don't draw it from between the edges of the circles. You draw from the data point itself to the dot that you made. Okay. And then you'll be good. So once you do that, you've got the raw graph itself. But they're asking you, what's the trend? Okay, so now once you finish this, and I'm not going to complete it for you, then you have to go back and say, I'm just going to do something here. 7 is 32, so 7 maybe we should do this. 7 is 32, 8 is 28, 6 is 26. Oops. 5 is 30. 4 is 15. Yeah. So heck, I'm doing your homework for you. So that's what your thing should look like. Now what you need to do is you need to draw a trend line. Trend line, remember, is going through as many data points as you can, but keeping it, but at least through the middle as much as possible. So I'm going to say, something like that. And that's what you're going to be doing. Okay? Okay. When am I going to see you next? Let me look. Let me look. So I'm going to see you when you hit page 66. So complete those and I'll see you in a few minutes. Okay, you're back again. We're looking at page 66. And what we see here is two interesting words, interpolation and extrapolation. Interpolate is to estimate a non-existing data point between two existing data points. And extrapolation is to go beyond. Extra means going beyond, okay? So David grew a plant. And he said, okay, I'm going to be a good boy and I'm going to measure this every day. So he started out really well, and he did. He first 3 days, and then he missed a day for some reason. And then he picked it up again on day 5 and completed to day 11. So the big question is, what would be the likely height of the plant on day 4? 2 ways to do this. One is by what they call by inspection, and that is you just look at it, look at where the line crosses the where the line crosses the day hash mark and read it. Okay. The other is to take the average between the 2 existing days. Okay. So like for me, I'm looking, here's 4, and it looks like it crosses right about there. So there's 20. This is 25. 22 and a half would be exactly halfway. So I'm going to guess that this is going to be about 22. Now, in order to write about 22, you use a little squiggly line like this, which in mathematical script, that means approximately. So I'm going to say approximately 22. The other way is to take the average between the two nearest points. Well, the nearest point here is easy because it's right on the line, which is 15. So that's 15. And the next one here is a little bit off the line. It's a little bit below 30. So I'm going to estimate that as being like 29. And I think that's a fairly reasonable. So the average, or X bar, is equal to 29 plus 15 divided by 2. And I know most of you guys have already done this in your head, or you say, wow, Mr. Hayden, 29 and 15 is 44. And anybody knows that 44 divided by 2 is, guess what? 22. So that wasn't a terrible estimation by inspection, okay? And I did use a term that you may or may not be familiar with. When you're talking about an average, this X with a bar over top, that means average. Not that you'll ever use that information, but if you're ever on the $1 Million Wall and they ask you about this, you can say, oh, thank goodness, Mr. Hayden told me that. So I owe him at least part of my money. Kidding you. Okay, so the other thing that we wanted to spend a few minutes doing is saying, okay, well, what happened here? Well, I'm a biology type guy. And so I look at this early going on and I think, okay, this is developmental stage for the newly emerging bean plant. It's trying to set up shop. Its new, small, fragile leaves have to grow a bit until they can actually capture as much sunlight as they can so they can do full-on growth. So that's the early developmental stage. Then we run into this happening here as holy smokies. That's the full growth spurt, or the average growth of a plant. And then what you see going on here, there's two things. This is flattened out, and then it goes up again to here. Okay? So what do you think is happening here? Well, I think it's reaching its maximum height. Down here, I'm wondering if David forgot to give it fertilizer and it ran out of nutrients, and then he said, "Ooh, I better give it some fertilizer," or he missed up on what do you call it? Feeding it water. Okay, so that what we did here is interpolation. That's interpolation. What we want to look at now is extrapolation. Now, extrapolation is to go beyond. And so they're asking what happened in day 12. So I'm going to say about here on the graph, that's about day 12. The next big question is, well, what's going on? Well, you have to look at the previous two data points to see what the trend is. So if I connect these two data points and I continue on, where those cross is going to be the likely position of my extrapolated data point here. Now you'll notice that it is not yet at 30 centimeters or 40 centimeters. So my guess is that it is at 39 centimeters. It was at 39 centimeters the day before. So it has actually reached its maximum height. Okay, that's extrapolation. Extra means to go beyond. So out here in no man's land is extrapolation, or some graphs will end and they'll say, what was it at day 0? And so you'd have to say, so for example, if this data point down here say that data point didn't exist. And they said, what do you think the data point was for day 0 based on this graph? Well, what you do is you take these two data points and draw a line down. And you can see that if you extrapolate that backwards, that it'd actually be a smaller value than what this graph gave us in the beginning. So there you go. Okay, let's see where you got to go to now. So let me see now. Yes, let's look at this one. I just wanted to make a comment before I turn you loose on these examples. Come on, share. Okay, trees, this you need to read this a little bit carefully. What these data points are is how much gas is in the tank. It's not how much you used, it's how much gas is in the tank. So if you started at 8 a.m. with 30 liters of gas, and then by 9 was down to 20, and then was down to maybe 17, same. What is happening here? Now, this is where you have to use your imagination. You have to use your power of interpretation here, okay? So for me, I would say, okay, 8 o'clock, she maybe had to drive into work. I don't know. She drove a distance in 1 hour, and she used about 10 liters. She drove a long way, actually, because even for a liter, 20 liters, she's driving a long way. And then slower driving or idling, nothing happened here. My guess is that she stopped. What happened here? What do you think happened there? More gas is in the tank. She went to a gas station. She got filled up. Okay. Okay, that's the only thing I wanted to show you about that. Stop share. So, let me see now. You come back to me at page 69. So I will see you then. Okay, welcome back. We're going to look briefly at sharing data or having two graphs on this, or two sets of data points on the same graph. Okay, so multiple line graph. And so what we're looking at now is housing prices between two major Canadian cities, between Vancouver and Regina. And customarily, when you do this, you can see the grid at the top. Come on, where is this? There you go. You see the grid at the top, and customarily, graphs that do this need to differentiate between the two data points on the graph, so they'll do it different colors. And you can see that the producers of the book attempted by making one darker, one lighter. Fair enough. I like to use color, whatever works. Okay. I just find it easier with color. So in this thing here, you would have done the same thing. It says displayed information on a broken line graph. And so your time is on the bottom, years, 5 years. And then if you look at the dollar figures, these are 132,000. So these are in thousands of dollars. So instead of writing on the side 700, 000, in the legend, you would write price in thousands of dollars. It makes it way neater and way more understandable. Okay, now what that means is, again, these values, 132, you're just estimating. You're trying to put a data point there. Okay, and again, you do well to put a circle around it. Anyway, this does allow us to look at, to compare two sets of data to see what was going on. And in this case, they're asking you to look at what happens in the first between 2006 and 2008, and then to look at what happens between 2008 and 2010. And so between 2006 and 2008, the trend line here for Vancouver is about like that. Okay, I've put it through 2 data points. The middle one is a little bit off. For Regina, it looks like that. So you should be able to see that Regina actually had a higher increase in housing prices than Vancouver did over that same period of time, even though there's a great difference between the overall pricing. Then when you look at the between 2006 and 2008, what you see is this. Here's Vancouver. And here's Regina. Regina pretty much flatlined, whereas Vancouver took off. Comparatively speaking, if you look at these, this was flatter, up, dead flat, pretty much. Okay, so that is the value of doing multiple line graphs. Okay, so let me see where we go from here. Okay, so build your skills. So 971. So you're coming back to me on page 72. So complete those questions, and I will see you in a few. Okay, you're back. Okay, we're going to look at misleading graphs. They don't purposely try to be misleading. They just are. Okay. Now, in this graph here, the cost of sheet metal by a year, what it looks like is that there's great fluctuations up and down in the prices over 6. It says by year. It says by year, but that's actually a bit of a lie because each one of these points is 6 months apart. Okay. So what the misleading thing is down here in this bottom corner, that you'll notice that it goes from 0 to $500 like right away. There's nothing in between. Basically what they've done is they've taken the entire graph from 0 to 750, and they've ripped off the bottom and compressed it down and just brought it right down. Okay. Now, why is that misleading? Well, in a way, it gives a better understanding of what's happening at the top, but it doesn't give an overall view of what is the price in generally in the world. How much is it fluctuated overall? So if you look at the next page, you'll see the same data. You'll see the same data in what I would call a proper graph. And if you compare the two, you'll see, oh yeah, okay, it's a bit high, goes down, goes up twice, down twice, up and down, up and down, up and down. But then if you look at what, excuse me, the trend line on, trend line is about I don't think it's that much. I think it's more like that. It looks like there's been a huge fluctuation, but what we see here though is a general downward trend. Really, if you look at it as it says down here, the fluctuations in price are not that great. That's why it's a bit misleading. Okay. So, same thing is true. Page over, page 74. At Marcia's weekly grocery expenditures. You'll see that down at the bottom you have that funky rip, and so you need to answer the questions. And it says you draw a graph down here. Oops. Draw a graph, but go from 0. Right now, I think you'll find out that you look at this and the impression is, oh my goodness, the girl's gone crazy. She's buying everything in sight. But when you look at it over a proper graph, it looks like her increase in grocery costs could be just because the prices are going up. Okay, so let's see now. You come back to me now. You've got one more to do. Oh, no, that's it. So from here on, you need to complete to page 75. That is your for this unit. And then your homework, your overall homework for today includes everything you've done so far, and page 76, 77, 78, 79, which is quite a bit. And then the next time I meet with you, we will be doing bar graphs. So we've covered a lot of ground. That's why you have double blocks of this. So you've got a lot of work to do. Next day, bar graphs. If you have problems, get a hold of me. The information will be in Moodle, but it's going to be up to you. Okay? Chat with you later. Bye now.